My name is Angel Rodriguez, as you all know, and I'm extremely happy to be here. As a matter of fact, in the citizen seismological life that I've had, I can't imagine a better place to be. I live in Panama. This is Volcan Baru, our big volcano that we monitor. This is our building. It's 550 meters of office space and workshops, mostly workshops, about 300 meters of that. And when Paul called me, I said, well, what should I speak about? And he says, well, how about the past, present, and future of Raspberry Shake? It's hard to talk about the past of something that's only 14 months old right now, just born yesterday, as it were. But this is our network that we have right now. And I checked last night, and there are 541 stations that come online with over 1,000 channels coming in, because some of the stations now have 4 channels. And part of the magic of this project is the software. And so when a person buys the Raspberry Shake, they connect it to the internet, and if they don't have draconian network managers, the thing registers itself onto the servers, it finds the location of where it is, it puts the triangle on the map, and then it colors the triangle based on the noise at your particular site, immediately integrates that data stream into a seiscomp and starts using it for locations. And that happens without you doing anything. And that's the magic part. And to Mr. James Taylor, who loses sleep about how to lower the cost, I lose sleep over that every single night. And the fact of the matter is that the hardware can't get much cheaper. I mean, as much as we try, we can take a penny or two off the crystal or a 10 cents off the processor. 90% of the cost of Raspberry Shake is software. There are software programmers that outnumber the hardware programmers and the hardware designers, and really it's a group of people who, we don't all know each other. Half of us don't work at OSOP, half of us work in Russia and the United States and New Jersey and in Los Angeles. We do it all over the internet, and the software part is the part that really makes it all work. After Remy's presentation, I really realized, not having understood it before, that we really are targeting the citizen seismologist. I mean, the person that's interested in the waveform, the person that wants to know how it works, the person who shares the spectrogram of their washing machine because it's interesting in how it goes. And then somebody say, well, this is what it looks like for an LG 300. And you know, now so they're actually learning the seismology part of it by looking at the refrigerators and the trucks going by and the neighbors and the kids playing. It really is exciting to have that happen. For those of you that don't know what Raspberry Shake is, it's a little geophone that has been used in exploration seismology forever. It's well known. They make them by the gazillions. And a little card that takes that geophone and electronically extends the period from 4.5 hertz down to half a hertz. And it does it with some circuit magic in there. And it's the equivalent of having drilled a little hole in the geophone and pouring honey in it and then sealing it up again. So what it does is slow everything down. Instead of happening quickly, it happens a little bit slowly. It happens with the Raspberry Pi, a little bit of seiscomp thrown in, and we have that. This is a tool for the citizen scientist, somebody who really wants to look at the waveforms. And talking about the past, Raspberry Shake was actually born in 1994 at 7:30 in the afternoon, in the evening. And how would a person know that? Well, I had just gotten my first seismometer that I bought. It was an AS1. I remember my reaction when I opened the box. I looked inside and said, I paid good money for this. I just couldn't believe what was in the box. I mean, there was a pot to put oil in, and there was pieces of aluminum that had been cut, and I knew I could do better. And that's when I started making things. I was excited. And I had built it, and I put it in the workroom, and my wife called me to dinner. And we were halfway through dinner, and all the alarms went off and went SDR. I mean, it started making whistles and bells and everything, and she turned around, she says, if that thing's going to make that kind of a racket all the time, you're going to have to move it somewhere. So after dinner, I went, and an 8.2 had occurred in Bolivia, and my first seismometer within about 2 hours had recorded a major event. I mean, I was hooked. I wanted everybody to know how to do this. And so in August of last year, year before, 600 people sent us money and bought sight unseen, unproduced seismometer. And that's when it was born. So why did it take 22 years, 2 months, 8 days between getting excited about it and having been able to do something about it? And the answer in reality is that nothing was ready. Lots of school seismometers were out there. I can remember in 2010 calling Dave up and saying, hey, Dave, the Lippmann patent expired. And he says, what's that? And I said, well, that's the patent that Lennart uses to electronically extend those things they sell for $5,000. And what do you think? Oh, send it to me. And so I sent it over to him. And the next day he calls me up and says, well, I breadboarded that. It worked right out of the box. And so that started the period extension on the common geophone. And then SWARM in 2013. SWARM is the program used by the United States USGS volcano activity. It has a wonderful color palette. It's in Java. It runs on all platforms. It's visually wonderful to use. And in 2013, they began to read Miniseed. Otherwise, before that, they had a protocol called TraceBuff, if anybody really. And so another element had dropped in. There was an easy tool to look at Miniseed that was fun to use. You just clicked on the part of the heli, and then it would bring it up, and then you could look at the spectrogram, and you could see it in quite a few different ways. Just 3 years ago, we began to be able to produce surface mount things cheaply. And that is that before we produced them in the US, a little board the size of the one that is in the Raspberry Shake cost us $60. Now we can have it off in China. They actually work. They don't get the software. They just produce the boards. We program the software. And that has come down by an order of magnitude. I mean, these boards are very inexpensive now. They normally all work, every one of them. It's a very good company that we're working with. And then the Raspberry Pi Foundation, this magical thing that they produced. I can remember coming up to Brandon and saying, Brandon, you know, there's 11 million Raspberry Pis in drawers waiting for something to do. And he says, well, what are you going to have them do? And I says, we're going to have them do seismology. And that's exactly what happens. Our best seller is what we call the Magnitude 8. And it's just the geophone, the little board, and a plastic box. And the person already has the Raspberry Pi. They hook it together, and it works. And they have done a wonderful job of getting these computers out. I think now we're recognized as a partner, Brandon, the Raspberry Pi Foundation. We can now use their little logo and say we have a Raspberry Pi in it, and that's wonderful in itself. Our wonderful partners at GEMPA, the authors of SeisComp and the maintainers of SeisComp, and the programmers that GEMPA have now integrated. We're beginning to learn how to scale up. But the magic part is that these guys have managed it so that Raspberry Shake is running the latest transport protocols, CAPS, of which SeisComp is a subset, the SeedLink protocol. And it goes in there, and they automatically register it onto the database. They start locating with it right away. And quality control is done on the fly. I mean, that is before, SeisComp would say, well, you have a noisy station. We won't use it. Now they say your station was noisy 10 minutes ago, but now it's okay. The buses have gone by, so we're going to use your data. And we're learning to scale up because SeisComp before was all for broadbands. Most of the broadband installations were good installations. They didn't have to worry about that. But scaling up for noisy urban data is something that's happening now. Lots of software effort is going into that. Wonderful tools are being developed. And Kickstarter. 2009. This was the last piece that really worked. That is that in 2015, we ran a crowdsourcing campaign for a product, and it was a total bomb. We lost, I think that we were asking for $50,000, and I think we got $7. And what we learned there was that the people that we were targeting told us that they didn't care for this product. They just didn't want it. So we redid the thing and launched in 2016, and 600 people bought something that they hadn't ever seen and had not been produced and sent us $100,000 to get things going. That started the ball going. We've run another campaign that was also very successful. So with Kickstarter, what we have is a tool that instantly tells you if there are people interested in your project. So if you launch something and nobody buys it, you don't have to make it. You don't have to produce it. It's been solved for you, and that is wonderful. And we had to wait for all of these pieces. The RIDE had to wait for all these pieces before we could come up and have a Raspberry Shake. The software that's in there is phenomenal. I mean, maybe when you're there you can talk to Brandon about it, but it's really what makes this thing work. So present is that we have over 500 stations online. This is the map. It changes every day. If your station doesn't work, the dot goes off. If it comes back on, the dot comes back on. We have one of our users, one of our citizen scientists, has graphed it for us, the growth. These are stations as they come online over the 14 months, and he comes up. We have 133 stations in Europe. We have automatic locations now that are happening with Raspberry Shakes. We have EQ View, which shows you where the earthquakes are located. I mean, pretty normal seismology stuff. EQ Info, which is the app that now I understand is fully targeted at citizen scientists and not eyewitnesses. People who, when you open your app up and there's an earthquake, you can click on the earthquake and it shows you how your seismometer saw that earthquake. And it's really a very, very interactive, wonderful thing. We now can do PGA alarms. I mean, we now have enough software in there that it can calculate ground accelerations, so we can do things with that, which we haven't done yet, but we will. And several different new shakes are in the pipeline. Present, again, is that, for example, this little earthquake there, which I think was a 3-point something. I can't read it from here. All these stations that were used in that location are Raspberry Shakes. And this solution happened within less than a minute for this area. I have to say that we also use the public stations that are out there available for anybody to use. So already we have a tool where in certain places we have the density to do our own locations with our own stations. And if you were to go to Station View and expand this, there are probably 50 stations in SERA, 50 stations in the Bay Area, 100 stations in Oklahoma. Thanks, that's coming up very, very nicely. Still in the present. Near future, that is that it's present, is a little device that we call the Raspberry Jam. And the Raspberry Jam is a universal digitizer that will allow you to connect any sensor that has an analog output, that is your Slinky, your SEP, your homemade garden gate, your STS2, your L4, your Rangers, almost anything that you have already that has an output can be connected, and then it connects itself to the network, assigns it the proper name, and gets it on there. So if your school wanted to upgrade to the AM network, as it were, they could use this device and get that done. 100 samples per second. It takes active and passive sensors. And the way it's been built, and Dave has a lot to do with this, it looks like a Q330 with a gain of 1. So we can characterize that, and we can characterize lots of these other sensors like L4s, Rangers, AS1, Sync-Ly, so we can actually get some useful data out of it pretty quickly. In the future for Raspberry Shake, well, there's a lot going on. We plan to have some school-based stuff that we can develop for people, travel time tool where people can see the travel times of the many ways that Jamasize does it. We're going to have a new locating tool that Brandon was telling me about, that people can actually use their station as the primary, and then the stations that are around them to do local and regional locations in a very cute way, if you ask him about it, because I don't really understand it. I understand the hardware part more than real-time data services for observatories. That is, that observatories are already calling us and saying, well, we'd like to have these 15 traces. And then they can subscribe to that and they can get them, because the way it's been designed is the data is immediately useful to any observatory. The software just understands it. So if you have a SeisComp, you can incorporate the stations and use them in a scientific way. We want thousands of stations in the map. We're going to have community citizen scientists, seismology pages, personal locating tools. We have a shake to sound tool that I've already seen working. You can go select your Raspberry Shake, and then it downloads a little movie of the signal, and you can listen to it on your headphone. It just all does it by itself. What do we have? Well, we have a whole bunch of things on the future. And I wanted to keep this short so we had time for questions, so we'll have questions.
Right.
Yes.
We'll get the hang of this conference organising stuff in a bit. We've got questions, and now we'll use a microphone so people can be heard and recorded.
Thanks for that. It's a great talk. You talked about managing to get better signals out of noisy data. What's the lowest magnitude quake you can pick up?
Well, lowest magnitude, I think that we have a small network in Panama, and using unconventional tools, that is earthworm, because I can get the stations and made them a little local earthworm. I can see 2s, 1.9s with just 11 stations. It is on a volcano, so we have little seismicity there. But yeah, you know, the way the software works now, and Brandon can interrupt, is that SeisComp now dynamically looks at these traces, and if it's in a quiet period, if it's at night, lots of station gets involved. If the bus just went by, if the bus is coming by when it happens, well, it just discards that station. So I think you can, with the density, you'll be able to resolve sub-1s. There's no reason why not.
Thank you.
Hi, thank you. I would like to know if there is any plan to use, to integrate GPS for time reception and also to have some local storage. I mean, being able to use Raspberry without internet for some, let's say, local deployments or whatever you want.
Yes, we just, I think, published on the web store a GPS for a low cost that actually comes in through the USB port and has the 1 tick per second, so you can get timing accuracy when it's not collected. And of course, you can save to a USB or to the local internal memory. Yeah, that's sort of been solved. I'm sure there's lots of little things that'll have to be worked out, but that product is already out there.
That has been solved.
Yeah, it has been solved. It was never, and I have to start out that when we sat down and we were talking about this, I mean, intentionally Raspberry Shake 1D is a 50 sample per second. I mean, we put restrictions on it so that it couldn't be used for science in a way. I mean, it was maybe a naive thing to do. And then Brandon, when he went that year to AGU, got requests, so now you can see the sample rate has gone up. We're looking at better timing things. But in the citizen seismology philosophy of it, we were never looking at trying to compete with GoodAlp or STS2s or anybody else. It turns out that the data is good, and the timing question was a good question. So now we have accelerometers, combinations of velocity sensors and accelerometers, digitizers, because all those hardware things on the front end, you might say, are surrogate to the immense effort of software on the other side. So anything that we hook up to those things, and it could be temperature, it could be video, it could be just about anything, runs through the protocol, runs to the servers, and then can be served up and used in any way that. So we can do shake maps almost immediately because the new 4D has 3 MEMS accelerometers.
So I think this is the coolest project I've seen in a really long time. So thank you for sharing about this. So my question is, this is something I never really understood for a long time until I started looking at the range of different types of seismic networks a few years ago now. And I was comparing, for example, the traditional network approach, which is very expensive, with these other lower cost approaches. At the time, it was things like the Community Seismic Network out of Caltech and the Quake Catcher Network out of Stanford. And one of the things that was the challenge, or was a challenge, and I think was probably the biggest challenge for the Quake Catcher Network, was the retention of users. And so what they experienced was that people were the citizen scientists that were plugging in these accelerometers to their computers were incredibly enthusiastic, and they would put them on their computers, but there was an inevitable half-life over which they would lose interest and they would stop running it, or it would stop working. They upgrade the software on the computer, but they don't upgrade the software on the accelerometer, stuff like that. I wonder, maybe it's too early to answer this question, but do you have a sense of what the retention rate is when you, the sort of hobbyists that you described with the Raspberry Pi, they plug it in, it's all very exciting, but inevitably there's some half-life. Do you have any sense of what that might look like?
Well, we really don't. Like the project is really 14 months since we began shipping them, but I know that we had, when we were doing our initial conversations of the design and what we were going to do, we were going to have a recycle program. And we haven't gotten those people offer yet, but you know, if you got tired of your Raspberry Shake, you lost interest, we have a school in your area that you can send it to and would have an exchange program. But we haven't noticed that. We notice that the dots come on sometimes and then they go away, and we send out an email that says, you know, please reconnect if we can help you connect it. But it's been growing and growing and growing, as you saw on the graph, so we haven't seen that plateau yet, and it may or may not happen. I know that there are many that have been bought, many, I'd say maybe 40, 45%, that have never come online. People bought them, they got them for a Christmas gift, they got excited with the Kickstarter campaign, they got it, you know, they're busy, they work 12 hours a day, they haven't gotten around to it, and so for me, just getting them online would be a big challenge, and we're still in that growth phase, so I can't answer that just yet, but it will happen. Yeah.
So I'm going to do the question.
Got a question. His priority is right.
So as you say, a big part of your costs is in the software and the back end behind the Raspberry Shake, but all of your income comes from the initial sale. So do you ever envisage having to go to a subscription model for your users to actually pay for all of that back end infrastructure?
We talk about that a lot also, and how to monetize this, because we realize that ongoing cost of the software, the hardware development sort of slows down and even stops, but the software just goes on and on and on and on, and that doesn't ever quit. So we're looking at models where observatories or people who want to do it for commercial or government reasons can subscribe to stations and sell those services. I'm not sure where that can go, but we guarantee that the user will always have access to their data for free forever?
Yeah.
Forever.
Well, we limit the server right now to 2 years, but that's just because we had to put a number on it. There's really no reason to restrict the data if we have the server space.
That's right. So in the end, we're realizing that as we scale up from hundreds to thousands of stations, server costs become a real issue. Storage costs becomes a real problem. And so we're hoping that Remy will take the data and store it for us, or that John Tabor will convince whoever the powers to be are to take our data and store it for use forever. So the answer is the user will always have access to their data and probably their neighbor's data for a while, but that's something we just haven't solved yet. We're still in that growth phase.
Okay, just one more question. Oh.
2 more questions. She gets hers. You can ask me now. Chris.
Okay, Angel. When are you going to get into the now-quake warning market?
The what?
The now-quake warning.
The early earthquake warning?
Yeah.
Well, I do have strong opinions about that, but I don't think that that's something that we're looking at directly. I mean, it may be just a byproduct that happens when the density is big enough. LA can warn San Francisco and vice versa, but it's not one of the design parameters that we're barreling towards. I don't know if there's a real appetite for it.
Well, your equipment is a lot cheaper than the product they're selling to California.
Well, Paul,
Does the
you can
same
ask Paul
job.
that question. You could ask Paul that question because, but it's not a market. The early earthquake thing is, I'm not sure that it's, I don't get it. I technically understand that it can be done. When you come to the average person, you say, I can tell you 6 seconds before the car's going to hit you. I don't know how they react to it. Like I said, it's a question for Paul. For Richard, I'm sorry. It's just you want to?
There's 2 comments.
We had one more question that I'd like to field over there, and then. But Richard is in that every day, and I think that he can really help us understand that, because it really is something that I don't understand.
I guess the question that I had was that when you were talking about storage of data, we would like to be able to store our own data, but it seems to me in the work that we've done with the test instruments is that we can store the data on the card, but it's harder for us to get that into our systems. We run SeisComp3, we understand that SeisComp3 is sitting underneath it, but it's getting the data from that instrument into our version of that as well.
And you have a local SeisComp3 on your local network?
Yes, we do.
Well, you can just call the Raspberry Shakes individually and get the data. You don't need anybody's permission or any extra software.
Then we need to know how to do that.
Yes, that's an easy one. I think we can take that one and show you how to do that in just a few minutes. If your shakes are on your network, the data is yours, and you can get it, you can store it.
No, they're not on our network.
Well, and if you have access to the network, then you can bring them into your, I mean, it is fully SeisComp earthworm compatible. There's no restriction on your data.
Can we generalize that question? So what is your data policy? How openly do you share the data from the Raspberry Shake?
Well, I don't think it's very closed right now. On one of the servers that I saw, one of the data servers, we have a half-hour delay that's fake. I mean, we just introduce it, and I know that anybody can get the data, and that's a better question for the guys that do the business. And I have the extreme luxury of not having to worry about any of that. I just worry about making things and cutting them and designing them, and that's the fun part. Brandon is developing in conjunction with our partners at Gempa how that's going to happen. But can you just address it just quickly?
Yeah, we make a distinction generally between people that we call makers and hobbyists, people that are interested in doing seismology as citizens that don't have any responsibility to their government for locations and don't have any commercial interests, and then those people that have responsibility to the government and commercial interests. And so the people that are makers and hobbyists have free access to their data for all of time, and will also be able to stream real-time data from their Raspberry Shake and surrounding Raspberry Shakes in their community at no cost. But if you're a geophysical institute or you're a commercial entity, then the services that we provide for streaming the data and accessing the data have a cost. And the costs that we have right now, I think, reflect that we're paying for the services and not looking to make a fortune off of actually providing real-time streaming data services, but actually just pay for cost.
I think that the model we have now, and it's a model in evolution, is $1 per channel per month. So presently we're making about $60, $70 a month. But you know, we hope it'll grow. Well, thank you. I will be here for all the days, and I love to talk about this.